All right, welcome to Chapter 14, Section 2, called Parallel Lines and Proportional Parts. This is for Integrated Math 1, or IM 1. So just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a Submit Assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the Submit Assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click Submit Assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the grade book when you click that button so that your teacher can see what you've been working on and, hopefully it will improve your grade there. All right, on the side, we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. All right, so let's go ahead and take a look at this diagram. I don't know if they drew it to scale, so I guess we will kind of experiment with it here and see. I'm just copying a nice big section. And there it is. Okay. So let's try to zoom in on this guy. And I can actually erase that bit there. Oh, that was a little... Okay. So I'm going to try to do this in a way, let's see. I don't know if it'll actually let me grab that line and move it, but maybe it will. No, it's letting me grab the whole thing, but not necessarily that one line that I want to grab. What I want to see is this here. I'm going to go copy paste and now I can move it. So I've kind of stolen this one piece because what I wanted to show you is this is the mid segment. I just grabbed one of them. So D is a midpoint and E is a midpoint and I connected them. So we call that a mid segment. And so what the property is telling me is that it should be both parallel to CB, this other side, this third side that it's not intersecting, and it should be half the length. So if I grab this piece and I bring it over and it does look like it's to scale, which yay, that means that this works. Now I can see that half of this is in fact equal to the length of DE. And FB is the same length as CF. So it's half the length. There's two of them exactly the same and they're equal to this mid segment when it connects the middle of those other two pieces. So it's just kind of a quick visual showing you, how that works. So we have these two sides that work together, which we just saw. And then let's see, we have CF And so that would be parallel to this AB because it's that third side that it's not intersecting. And then the last one, let's see, we'll make the last one pink here. We have EF, and then that would be parallel to this guy here, which would be CA or AC. So it's just kind of a quick way. I just wanted to color code that so we could kind of see how these pieces work together. And now we're going to fill in some of the given here. So suppose the DF is 34, and AC, which is the whole side here, is 36, and BC, which is the whole side on over here, is 72. So now it's asking us to fill in the other 3 lengths. Because remember, it's a triangle, so it's 3 sides, but then we also have this inner triangle with 3 more sides. So if we are given 3 things, there's 3 more pieces that we can fill in with that, potentially. So the first one is AB, which is this side. So if this is 34, remember that means this guy's 34 and this guy's 34, because I could cut this piece and it would fit perfectly right on top of there. So the total length is going to be 68. Oops, darn it. And then if we have DE, so DE is this piece here, so and that's parallel to this other blue one. So remember, if the whole thing is 72, I want to split it in half. So I'd have 36 and 36, and that's what this one's going to be. They're all the same length piece when I cut this guy in half. So this is 36. And BE, so same thing. BE again. Interesting. Okay, so we're not actually going to use this 36 at all, because they're not asking us anything about EF. But BE, we already filled that part in when I was talking about AB here, which is 34. Alright, check. Perfect. So the next guy, we're going to be taking a look at proving the triangle midsegment theorem. Just walking through these kind of steps. So we're going to find the midpoint of a couple sides, and then we're going to test the slope, because we want to prove that, number one, we're testing slope and the length. So we're going to, just like we did on this triangle, we're going to show that the lengths are, in fact, half. They're this, the long one is twice as long as the short one, or the short one is half the length of the long one. And then the slopes are going to show us that they are, in fact, parallel. If 2 lines have the same slope, it means they are parallel. So that's why we're going to go through and test those 2 different things there. So R, they want the distance of R and the coordinate of R and the coordinate of S, and these are midpoints if we read this direction. So note that the triangle XYZ has vertices X, Y, and Z, and I didn't read the full vertices there, but suppose the R is the midpoint of XZ, so we have XZ here, and let's see, I'm going to grab that just so that I can, come on now, where is it? Oh, there it is. Okay, so now I've got my graph copied over and I can kind of look at that. So we're talking about XZ, so that's this one here. We want to find the midpoint of this one here down on the bottom, and then the S is the midpoint of YZ, which is just this one on the side here. So we're going to find the midpoint of these 2. We could have done XZ and XY. We could have done XY and ZY. They just chose these 2 sides. It's really, you can do this with all the different sides of the triangle. So we're going to go through and we're going to find the midpoint of these 2 pieces. We need to use the midpoint theorem to do this because it's not a vertical line or horizontal line. They're a little diagonal, so we can't just count to the middle. So we're going to do, the midpoint theorem says if we add together the x coordinates and divide by 2, that'll snap us to the middle. So if I go -6 plus 4, because it's -6 and 4 for the x coordinates, and then I'm going to divide by 2, that is -2 over 2, which is just -1. So that's my x coordinate for my midpoint here. And then I'm going to go -8 plus -6. So -8 plus -6 over 2, that's going to give me -14. over 2, which is negative 7. So I'm going to go negative 1, negative 7, right there, and this is the point R. So negative 1, let's put this in, negative 1, negative 1, why is 1 not typing? There we go, and negative 7. Alright, so now we're going to do the same thing for S. So for S, we're going to go going on this direction, so we have 4 and 2, so we have 4 plus 2 divided by 2, so we get 6 divided by 2, which is 3, and then we have negative 6 and 4, so negative 6 plus 4 over 2 equals negative 2 over 2, so negative 1. So I'm going to go 3, and then negative 1, sorry, not positive 1, right there, boom, and there's our coordinate for S. So we have 3 and negative 1. Alright, now we want to know what the slope of RS is. If I connect these points here, RS, like that. So the slope of this guy, I can just look at rise over run. So how far up do I need to go to get here, and how far over? So my rise would be 1, 2, 3, 4, 5, 6, and my run would be 1, 2, 3, 4. So I'd have rise over run, and I can reduce that, 3 over 2, 3 over 2, and now I'm going to do the same thing for x, y. So this line that I didn't find anything on, but I didn't need the slope. This is the one that's going to be parallel to. So same thing, I'm going to go, how far up do I need to go? How far over? So for this one, I know I'm down here at negative 8, so I have to go up 8, and then I have to go an additional 4 more. So this is 12. And then for this one, it's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8, 12 over 8. If I reduce this, these divide by 4, right? So that's 3 over 2 again. So that's exactly what we were hoping to find, is that these slopes are the same. That's proving that these two lines are parallel. Alright, so for the next piece, let's see, we're going to do the distance formula. I'm going to get rid of a little bit of this stuff. So now we want to find the distance of these two lines. So we want to find the distance of xy and the distance of rs, because we want to prove that rs is half of xy. So we need the distance formula. So in the distance formula, we're actually going to be using partially the slope formula, a little bit in it, because we find the difference of x and the difference of y again. So with this one, it was, let's see if I can, nope, it's not going to let me go back too far. So if I kind of go back and I just look at this again, the difference in y was 6, because I had to go up 6 units, and I had to go over 4 units like this. So the distance formula is the square root, it's the difference of the x's, so x1 minus x2, which is 4. We did that already visually. And then we square that, plus the difference of the y's, which is, just y1, or y2 minus y1, which would be 6, like that. So we already kind of did the calculation, just didn't finish it. So now we have 16 plus 36, because I'm squaring those two numbers. And then we would have d equals 52 square root. And we're going to leave that, give exact answers in simplest form. So that means if we could take out a square, then we would want to. So let's see, does this divide by 4? So if we divide by 4, we get 1 and 3. Ooh, it does divide by 4. So it's 52 is 4 times 13. So 4 is a square root, and a square root means what number do I multiply by itself to get to that number? Well, I'd multiply 2 by itself to get to 4. 2 times 2 is 4. So I can take out 2, and the 13 will stay root 13. So since it says simplest form, it's going to want us to do this. Take it out of the square root. But we don't want to take the square root of 13, because then we're going to have decimals, and that's not an exact answer because we'll have to round it off. So we don't want to do any rounding. So here, let me Oh. Alright, getting rid of a little bit of stuff there so I have room to do the next one. So we're going to find the distance of xy now. And remember, that was going up 12, so that's the difference in my y's. And we went over 8, that was the difference in the x's. So we have the square root of 8 squared plus 12 squared. And again, I'm simplifying that a little bit because we already have taken the difference of. And when you're looking at the distance formula, it's literally x1 minus x2 squared plus y2 minus y1 squared. Well, this is run. That's why I used 4 here, and I'm using 8 for this one. That's our run. And this is the rise. The difference in the y's is the y. So I'm just kind of simplifying that by using rise and run since we've already done it. Getting rid of that stuff again just so I have room to write all this stuff. Equals, we have 64 plus 144. So we get, let's see, we get 8, 10, and 2. So 208. And I believe we're going to want to end up with 4 root 13, something along those lines, if we're proving that it's twice as big. So what I'm thinking is this divides by 16. So let's try it. If we divide by 16, it goes in 1 time for the 20, and we have 4 left over with 48. And let's see, 16, I think that would be 3 times 18 and 4. Look at that. So it goes in 13 times, and it's 16 times 13. So what number multiplies by itself to get to 16? Well, that would be 4. No number multiplies by itself. No whole number multiplies by itself to get to 13. So we leave it alone. So I was just kind of guessing a little bit there that it was going to be 16 to get the result I wanted. Instead of having 2 from my square root, I wanted 4 because that's twice as big, right? And we're proving that this is twice as long. So that's kind of how I made that decision. The relationship between RS and XY is an example of the following rules. A segment that joins the midpoints of 2 segments of a triangle is perpendicular to the third side, parallel to the third side, neither parallel nor perpendicular. So we proved that it's parallel because the slopes are the same. And the length of the midsegments that join the midpoints of the 2 sides of the triangle is the same length, twice the length, half the length, not related. So make sure that you're choosing the right one because it's either going to be twice or half depending on which one we're talking about. So it's the length of the segment that joins the 2 midpoints. So we're literally talking about this middle one here. What's its relationship? So the length of the segment that joins the midpoint of the 2 sides is half the length of the third side. If they were asking about the third side, then we would say it's twice the length of the midsegment. So just be careful about, the way you're reading that because it makes a difference. Alrighty. I'm going to keep moving here. Let's see. So this one, I'm going to copy this diagram just because it gives me a little bit easier piece to write on. So we have some properties when we get parallel lines and triangles that we definitely want to acknowledge here. And this is a good opportunity also. If you don't know what to do here, and if you didn't know the properties that we're about to look at, you wouldn't necessarily know where to move forward with this. So you'd want to click on example so that you could see what are the properties here. And the first thing they have you do is kind of separate it out because it makes 2 different triangles. We have the larger triangle and we have the smaller triangle when we have this happening. So we're not talking about midsegment anymore. It's just a line that's parallel to the third line. It's going through the triangle, so it's cutting the sides, but it's not necessarily cutting them in half like we were talking about with the midpoints. But it still has a very special relationship. So EC, which is the whole side, and EF, which is the portion, ED, whole side, EG, which is the portion, and then we have CD, which is the whole side, and FG, which is the parallel line. So it's kind of whole side to, I'm going to say top point, but make sure when I say, or top section, top segment, And what I mean by top segment when I'm saying it too is I'm assuming that the triangle will be right side up and we're going from the point down. So just be careful about that. Or I can say not smaller segment. I don't want to say smaller segment because that's misleading, because then you might think that it's FC. So we can use this proportion here to help us solve for some of the missing pieces. So let's go ahead and take a look at this guy. So it gives us, we know that the sides are parallel. D is parallel to GH. And then FG is 21. HE, which is this one down here, is 12. FH is 28. And they want us to find GD, which is this piece here. So they want to know, what is that piece over there? So if we use the proportion, we're not really going to do anything with the parallel lines. I don't know anything about them other than they're parallel, but we are going to use the whole side, which is FE, over the top side, or from the vertex to the parallel line. So that's FH, and that's going to equal the whole side of the other segment, or if we were looking at the parallel lines, it'd be the longer parallel line. So in this case, we're looking at the other side, FD, to that first segment, which is, I'll do a little line here like I did on the other side, FG. So now let's go ahead and fill this in. So FE, well, we know that it's 28 and 12 for the whole thing, so we're just going to combine them. So we get, let's see, 2, 3, 40. We get 40 for the length there, because I just did 28 plus 12. FH was given to us, that's 28. FD was not fully given to us, but we know that we have 21 and we have X. So again, we can just add those together like that. 21 plus X is FD, that's the whole length. And then FG is the 21, like that. So now I can do this proportion. I have a ratio equaling a ratio, so we can go back to proportion, so we can just multiply these together. And they did give me a calculator, which is very nice of them. So 40 times 21, and we get 840 equals, and we'll do the cross multiplication this way. So remember, you're distributing, this is 28 times 21 plus X. That's like, it's in this parentheses. I have to distribute this 28 to both pieces. So I need to go 28, come on, 28 times 21, and that gives me 588 plus 28x. So I have my x value still here. So to solve this, I'm going to start getting x by itself. I'm going to subtract the 588 from both sides. I'm really sloppy. My pen's arguing just a little bit here for some reason. There we go, 588. Ooh, that is not what I wanted, silly pen. Alright, so we're going to have 840. Excuse me, that's 588. So we get 252 equals 588 minus 588 cancels, and I have 28x. So I'm going to go divided by 28 equals, because I'm dividing by 28 on both sides. Forgot to write it down. Sorry, just started doing it. 9 equals 28 divided by 28 cancels, so we have x. X is what we're looking for, right? That's why I gave it an x. I don't know if I actually explained at the beginning of the video. I just kind of put the x there because I said this is what we're looking for, and I assigned it x. Could have assigned it any variable I wanted to, but by solving it this way, we solved for the piece that we were looking for. All right. So the last one here, we're going to look at a proof. So remember, when we have a two-column proof, we have statements and we have reasons. We have to go through and we have to decide, what are we given and how do I keep moving forward, with my end goal being to prove the statement that they're asking me to prove. So use the given information to complete the proof of the following theorem. If a line parallel to one side of a triangle intersects the other two sides, so we can see that's happening here, then it divides the two sides proportionally. Not cutting them in half or anything, but proportionally, just like we saw. We have S SR over SU, ST over SV. If we looked at the parallel lines, it'd be RT over UV. So we're going to prove that that's true. What we just used is true. So they already gave us the given. They put it down here. So the given was that the two lines are parallel. The line passing through is parallel to the third side. So they put it down here already. It's given. And then they say SRT is congruent to SUV. So SRT is congruent to S, and I'm going to actually, I like being able to draw on my diagrams, so I'm going to copy this guy and give myself some extra room. I'll just erase that extra stuff. So it's so much easier to mark the diagram than try to remember it all. So, and I know we don't all have the ability to just kind of draw the way that I'm drawing. I'm just going to make this a little bigger. But you can just very quickly draw this triangle too, and that would work just fine. You don't have to copy and paste it into a program like what I'm doing. I'm just being a little fancy with it. All right, so we have these two are parallel. That was our given. And then the next one they're showing us for step 2 is that SRT, so this bottom angle, is congruent to SUV. So we're showing that these two angles are congruent. And what they're doing is they're focusing on the only piece of given information that we have, which is those two parallel lines. So if we have two parallel lines, and this is a transversal at this point, we're kind of focusing on that being transversal, and these two parallel lines kind of would continue through, transversals passing through them like that. So if we kind of go back to those parallel lines, then these pieces are in the same relative position on the diagram, meaning that they're both above their parallel lines and they're both to the right of their transversal. The other thing you could also just notice is that this one looks like it could just slide right down into this guy here. So it's not turning around in any way, shape, or form, it's just kind of sliding either up or down. So that's what we call corresponding angles. So we just want to go down, and if we have parallel lines, so we do have parallel lines, then corresponding angles are congruent. So I want to make sure we're grabbing the right one, because if you notice there's one, if we have corresponding angles, then the lines are parallel. We already know the lines are parallel. We're starting with parallel lines and proving or using that to show that the corresponding angles are congruent. So make sure you're just choosing the correct way, because there's always the theorem and then the converse of the theorem. Angle S is congruent to something, and it's telling us it's the reflex property. Remember, reflex means that we're proving something's equal to itself. So it's going to be angle S. I already know that just because of the property they're using. And the reason they're doing that is because we're sharing this angle up top here, right? They both share angle S. So angle S is congruent to angle S. And then they're jumping into triangle RST is similar, that's what the little wavy means, similar to USV. And they're doing that immediately because now once you have angle similarity, so I have two angles of the larger triangle are congruent to two angles of the smaller triangle, then I can say that they're similar. The angles have to be congruent, two of them have to be congruent in order to say that the triangles are similar. So I'm going to go down here and choose angle similarity. So why are we proving the two triangles congruent? So now, if we know that they're similar triangles, the idea of a similar triangle, the entire idea of a similar triangle is that the sides are not congruent, but they are proportional to each other. So they've been increased or decreased by the same factor for these ones. So if I have RS, which is the whole length, and US, then if I do the same thing on the other side, ST, which is the whole length, and VS, so this one I want to make sure it's, darn it, TS. I'm not sure if it would ding me for going the other direction, but TS, because they went RS, so I'm going TS from the bottom, just to make sure I'm going the same direction they're going for whatever reason. So the similar triangles are proportional. That's all it's trying to say. So if I have this one, which is RTS, and it's similar to this smaller triangle, which is USV, so now I have RS and SU, or US. And then I have TS and VS. So we're just grabbing the different sides of the triangle there to show that they are congruent. And when I mark these, so we can see, we do in fact have angle, angle. I have one blue angle and one red angle from each of the triangles. And a lot of the time I even say this in the videos not to use color coding, because there's all kinds of reasons that color coding doesn't come through. You know, for some reason your computer doesn't show the same colors, or if, you know, maybe we're a little bit colorblind with some of that stuff and we can't see, because some people can't see reds, or they can't see blues. You know, so most people are not completely colorblind when we're talking about that, but sometimes we can't see all of them. So if I just do one mark on them, there are some reasons why some people wouldn't even be able to see them. So just a quick tutorial on why you should always do more than, you know, one arc instead of just different colors. All right, so we filled in our proportion. The sides of a similar triangles are proportional. So now we have RS equals RU plus US. Okay, well, if I'm looking at RU or RS, all they're doing is adding the two segments together that create the entire side, right? So this is just segment addition. So now we're relating the entire side that we just talked about to the two pieces that create that side. Let's see, did I pass? I must have passed it. Segment. There it is, segment addition property. And they're doing the same thing for the other side. We have TS, and that's going to be equal, so this whole segment is going to be equal to the two pieces, the two segments that create it. So again, we're just going from the entire side, separating the whole thing, and now we're kind of putting it back together with this parallel side here and saying, okay, but we know that this whole side is here, but it is equal to these two smaller pieces also. So segment addition, there it is. Okay. So now what are they doing? Substitution property. So I have a clue as to what they're doing here when we have fill in the blank. RS plus US over US. So if we kind of go back up here to step 5, we had proportion that was RS over US. And now they've changed it. It's still over US, but now it's RU over US. Well, in step 6, we showed that RS, which is this guy, is equal to RU plus US. So we're replacing, instead of RS in step 5, in step 8, we're replacing it with this segment addition we just proved, or we just, not proved, but we just included. So this one, instead of TS, which was step 5, we're going to replace it with TV and VS, because that's what we just showed that TS equals. We're just substituting these pieces. Alright, so then down here it says fractional algebra. So now they're showing us we can split these so that they're both being divided by US, they're both being divided by VS, so they're just splitting that apart. And then all of a sudden we have ones here instead of this US and VS over VS. Well, anything divided by itself is 1. Even though, you know, it's a segment, we don't necessarily know what it is. It's the segment divided by itself. So anything divided by itself becomes 1 and 1. And then all of a sudden, the ones disappear. Well, what happens here is if I subtract 1 from either side, 1 minus 1 is going to disappear or eliminate. So I will just be left with the pieces, these two fractions, RU over US and TV over VS. And so I got there by using the addition subtraction property, specifically subtraction, because I subtracted 1 from both sides. So now we can go ahead and check this guy. He should be good to go. All right. So it's a little bit of a roundabout. You have to do, go through quite a few steps there to get from just the two parallel lines and work through all these other pieces that we already know. So that's one of the big things with the geometry sections here is we definitely need to be, studying and paying attention to all these theorems, definitions, postulates, everything that we're getting along the way, we will end up using again. And sometimes some of the smaller, obscure ones that we don't use very often do pop back up, and we do end up using them again. But definitely segment addition, the similarity properties, or the congruence properties when we're in that section. The parallel line properties, those do not go away. We use those all the time. This fractional algebra one does not come up very often, but it is a property. If I'm dividing a binomial, by a number, I'm actually dividing both numbers by that number. So I can split it into fractions, things like that. All right, so that was section 4. I will see you in section 5.